Part B. A car manufacturer tests different heating elements by measuring how long it takes to ice to melt. During the test, some variables must be controlled. Identify 2 control variables in the car manufacturer's test and tick 2 boxes. So 2 control variables when measuring how long we're looking at the heating elements, different heating elements. So different, that means that's our IV, and we're measuring how long it takes to melt, which will be our dependent variable. So what things might the manufacturer change? Well, they'll probably what things must they keep the same? Well, the colour of the car is irrelevant. The current in the heating element, absolutely, because the higher the current, the more heat it will give off. The mass of ice, yeah, absolutely. The mass of ice, the amount of ice. Mass is a much better word than amount. Size of the car is irrelevant, and the time it takes for the ice to melt. Well, that's what it's. That's the dependent variable. Some of the energy supplied by the heater causes the ice to melt without the temperature of the ice increasing. What is the name given to this energy supplied by the heater? And tick 1 box. So what is the name given for that, where the temperature doesn't increase? Okay, so the temperature without the temperature increasing. So if you can remember here, this is the heating and cooling curve where we get this to happen. Temperatures here. Okay, we end up with this rather cool curve like that. Time over here. This is solid, this is liquid, and that's gas. Here we get melting. Here we get boiling. Okay, so at this point here the temperature doesn't change, and at this point here the temperature doesn't change either. And we call this a latent heat. So it's one of the latent heats, but it's going from solid to liquid. So the ice is melting. So the solid to liquid will be, this one freezing would be liquid to solid. Vaporization would be liquid to gas. Fusion is where we get solid to liquid. Okay, so it's that one there. When the heater is supplied with 120 joules of energy each second, the internal energy of the ice increases by 45 joules each second. Use the following equation to calculate the efficiency of the heater, okay, and then give your answer to 2 decimal places. So it's worth 2 marks. So we've got efficiency equals output divided by input. It's useful output. Okay, so what have we got? Well, we know we've got it's supplied, we've got input is 120 joules. We know the internal energy is that's the output. It's 45 joules. So substitute our numbers in. We get useful output is 45 divided by 120 equals 0.375, but we have to give the answer to 2 decimal places, so it's 0.38 to 2 dB. Okay.